In this video, I'm going to show you some experiments I did to study the effect of carbon dioxide and humid air on infrared absorption versus dry air. And I'm going to show you some data that shows really why you shouldn't do this. I will just first of all just show you the experimental apparatus, and then we'll go into some data and what we found doing this. First of all, this is showing two globes here with a 60-watt infrared bulb, and we could put different gases in either one of these globes here. That was one setup. This is another one, very similar, but in this case I used a old iPhone as a timer, and this one over here I used an old cock radio as a timer. That was way not accurate enough, but we'll play a little bit of this. This is a time-lapse clip showing you the impact here, CO2 on this side, dry air on this side, and it shows basically how the floats come down. If you see my other video on how Galileo thermometer works, you'll understand that the floats drop when the density of the liquid hits the calibrated density of those floats. This is another setup that I used, and I'm not going to try to speed this up a little bit. This is where I used a single Galileo thermometer and a standard thermometer. I've called this a mercury thermometer in some other slides, but it's really, I think, not a mercury thermometer. But in this case, I wasn't using the Galileo thermometer. I was simply going by this temperature rise here, going from 73 degrees up to 88 degrees. And we'll go ahead and stop that because that just shows what I wanted to, that particular apparatus. This is a little video clip showing
part of a demonstration
basically
of the Galileo thermometer and
how we did this.
An experiment to look at the effect of greenhouse gases like carbon dioxide. Room temperature 74 degrees. Come over here to this arrangement. So we've got a glass globe on a Pyrex bulb. Everything's sealed with gaskets. If you look, it's a little hard to see, but inside that silver object there is a desiccant. It's used for removing moisture out of gun cases, things like that. And inside the glass globe, we have a Galileo thermometer and a standard thermometer. And over here is a 250-watt heat lamp. We call this the drum.
That shows that particular experimental design, how I use desiccant to dry out the air. This is another one showing how we purge with carbon dioxide.
These experiments, humidity was created by just adding about a quarter cup of water to the Pyrex bowl, of course without the desiccant in it. To purge with CO2, I use this, actually a paintball CO2 cylinder. Doesn't matter where you get the CO2 from, that was just conveniently purchased at a sporting goods store. I could open the top of this, purge it, and close it, and also purge down through this hole that was put down here to have a way to purge it from both ends, top and bottom. And that seemed to work pretty well.
All right. So let's look at some data, what we got doing these experiments. And let's see here, let's open up our PowerPoint. Okay. Basically, I'm trying to show you why a Galileo thermometer is a bad choice to measure the greenhouse gas effect. Our hypothesis in experimental design was that carbon dioxide, humid air, or humid air plus carbon dioxide will warm up quicker than dry air when exposed to an infrared heat lamp. Try to visually demonstrate the effect using Galileo thermometers. Two identical 18-inch Galileo thermometers were purchased and used for the experiments. A standard thermometer is also used with a single Galileo thermometer. And this is the data. There's a lot on here. I'll try to explain it without dragging it out too long. This is the double Galileo thermometer data. This is the single Galileo thermometer plus, like I said, mercury thermometer. It may not have had mercury in it, but standard thermometer. Up here, we ran this time for quite a while in minutes, usually over an hour. Down here, the time measured is in seconds. And as you can see, the left thermometer, right thermometer, we have dry air, humid air, dry CO2, and humid air, that is water with CO2 purged into that globe. And I got the average of these data points. Some of them I just had one data point and then the standard deviation. If you look at the dry air over here on the left thermometer, the average 67.5. The right thermometer for all this data, significantly more for exactly the same setup, making sure all the distances to the infrared bulb and everything were the same. So big difference between those thermometers. And so you can't really depend a lot on this data. This shows a slight difference. The dry CO2 actually taking a little bit longer to heat up than the dry air, but I wouldn't put much stock in that data. On the right thermometer, the dry CO2 took a little longer to heat up than the dry air, but again, I wouldn't put a lot of stock in that. Down here on the single Galileo plus the standard thermometer, just 3 data points of each setup, dry air and then humidity as water vapor plus the CO2. Average here 270.67 seconds. This was using that 250 watt heat lamp and it really heated it up quickly. That could have also been an issue. And over here 259.7. Now that's the time to go from 73 degrees F up to 88. Whereas up here we were simply looking at the time it took for that top 84 degree F float drop in the Galileo thermometers. Down here we're looking at the standard thermometer. And so there is a difference. In this case, it's showing the humidity plus CO2 is actually heating up a little bit quicker. But again, I would not put a lot of stock in this data. My conclusions are a significant difference in accuracy was observed between the 2 thermometers. Using one thermometer with different gas environments is better than comparing data between 2 of these thermometers. But to summarize, I recommend a completely different experimental design to demonstrate the greenhouse gas effect. And I've got another design I'm working on. It'll have a longer path length for the gas to absorb infrared radiation and hopefully be a lot more accurate. And this was interesting from the standpoint of just using the Galileo thermometers. They're very cool devices, and I thought it might be a way to visually demonstrate the effect, but I couldn't do it with this particular experimental design, and I wouldn't recommend that you do this either, but I would recommend you be innovative and try something. It's fun doing these things. Thanks, and hope you got something out of it.